للعالمين.
All right, this is CS50, and this is week 6, wherein we finally transition from Scratch to C to now Python. And indeed, this is going to be somewhat of a unique experience in that just like a few weeks past, perhaps for the first time, and now today, you're going to learn a new language. But the goal isn't just to throw another fire hose of content and syntax and whatnot at you, but rather to really equip you all to actually teach yourself new languages in the future. And so indeed, what we'll do today, what we'll do this coming week, is sort of prepare you to stand on your own. And once Python is passé and the world has moved on to some other language in some number of years, you'll be well equipped to figure out how to wrap your mind around some new syntax, some new language, and solve problems as well. Now, you'll recall in week 0, this is where we started, just saying hello to the world. And that quickly escalated just a week later in C to be something much, much more cryptic. And if you've still sort of struggled with some of the syntax, find yourself checking your notes or your previous code, like that's totally normal, and that's one of the reasons why there are languages besides C out there, among them this language called Python. Humans over the decades have realized, gee, that wasn't necessarily the best design decision. Or humans have realized, wow, you know what? Now that computers have gotten faster with more memory and faster CPUs, we can actually do more with our programming languages. So just as human languages evolve, so do actual programming languages. And even within a programming language, there's typically different versions. We, for instance, have been using version C11 of C, which was updated in 2011. But Python itself continues to evolve, and it's now up to version 3+. And so there, too, these things will evolve in the coming days. Thankfully, what you're about to see is hello world for the 3rd time, but it's going to be literally this. None of the crazy syntax above or below, fewer semicolons, if any, fewer curly braces, and really a lot of the distractions get out of the way. So to get there, let's consider exactly how we've been programming up until now. So you write a program in C, and you've got hopefully no syntax error, so you're ready to build it. That is, compile it. And so you've run make, and then you've run the program like /hello. Or if you think back to week 2, where we took a peek underneath the hood of what make is doing, it's really running the actual compiler, something called clang, maybe with some command line arguments, creating a program called hello, and then you could do /hello. So today, you're going to start doing something similar in spirit, but fewer steps. No longer will you have to compile your code and then run it, and then maybe fix or change it, and then compile your code and run it, and then repeat. The process of running your code is going to be distilled into just a single step. And the way to think of this for now is that whereas C is frequently used as indeed a compiled language, whereby you convert it first to zeros and ones, Python's going to let you speed things up, whereby you, the human programmer, don't have to compile it. You're just going to run what's called an interpreter, which by design is named the exact same thing as the language itself. And by running this program installed in VS Code or eventually on your own Macs or PCs, this is just going to tell your computer to interpret this code and figure out how to get down to that lower level of zeros and ones. But you don't have to compile the code yourself anymore. So with that said, let's consider what the code is going to look like side by side. In fact, let's look back at some Scratch blocks, just like we did with C in week 1, and do some side by sides. Because even though some of the syntax this week and beyond is going to be different, like the ideas are truly going to be the same. There's not all that much intellectually new just yet. So whereas in week 0, we might have said hello to the world with this purple puzzle piece, today, of course, or rather in week 1, it looked like this in C. But today, moving forward, it's going to quite simply look like this instead. And if we go back and forth for just a moment, here again is the version in C, noticing the very C-like characteristics. And just at a glance here, in Python, I claim it's now this. What do you apparently need not worry about anymore? What's gone? So semicolon is gone, and indeed, you don't need those to finish most of your thoughts anymore. Anything else? So the \n is absent, and that's kind of curious because we're still going to get a new line, but we'll see that it's become the default. And this one's a little more subtle, but now the function is called print instead of printf. So it's a little more familiar in that sense. All right, so when it comes to using libraries, that is code that other people have written, in the past we've done things like #include cs50.h to use CS50's own header file, or standard IO, or standard lib, or string, or any number of other header files you have all used. Well, moving forward, we're going to give you, for this first week a similar CS50 library, just very short-term training wheels that will quickly take off, because in reality, it's a lot easier to do things in Python, as we'll see. But the syntax for this now is going to be to import the CS50 library in this way. And when we have now this ability, we can actually start writing some code right away. In fact, let me switch over to VS Code here. And just as in the past, I'll create a new file. But instead of creating something called .c, I'm going to go ahead and create my first program called hello.py, using code space hello.py. That, of course, gives me this new tab. And let me actually quite simply do what I proposed, print, quote unquote, hello world, without the \n, without the semicolon, without the f in print. And now let me go down to my terminal window, and I don't have to compile it. I don't have to do // I instead run a program called Python, whose purpose in life is now to interpret my code, top to bottom, left to right. And if I run Python of hello.py, crossing my fingers as always, voila. Now I have printed out hello world. So we seem to have gotten the new line for free in this sense, where it's automatically happening. The $ isn't weirdly on the same line like it once was in week 1, but that's just a minor detail here. If we switch back to now some other capabilities, well, indeed, with the CS50 library, you can also not just import the library itself, but specific functions. And you'll see that temporarily, we're going to give you a helper function called getString, just like in C, that just makes it work exactly the same way as in C. And we'll see a couple of other functions that will just make life easier initially, but quickly will we take those training wheels off so that nothing is indeed CS50 specific. All right, well, how about functions more generally in Python? Let's do a whirlwind tour, if you will, much like we did in that first week of C, comparing one to the other. So back in our world of Scratch, one of the first programs we wrote was this one here, whereby we asked the human their name. We then used the return value that was sort of automatically stored in this answer variable as a second argument to join, so that we could say hello David or hello Carter. So this was back in week 0. In week 1, we converted it to this. And here's a perfect example of things like escalating quickly. And again, this is why we start in Scratch. There's just so much distraction here to achieve the same idea. But even today, we're going to chip away at some of that syntax. So in C, we had to declare the argument as we had to declare the variable as a string here. We, of course, had the semicolon and more. Well, in Python, the comparable code now is going to look more simply like this. So semicolon is again gone on both lines, for that matter. So that's good. What else appears to have changed or disappeared? Yeah. Yeah, so I didn't have to specifically say that answer is now a string. And indeed, Python is dynamically typed. And in fact, it will infer from context exactly what it is you are storing in that variable. Other details that seem a little bit different. A little bit different. What else jumps out at you here? I'll go back. This was the C version. And maybe focus now on the second line, because we've rather exhausted the first. Here's now the Python version. What's different here? Yeah? Yeah, there's no %s anymore. There's no second argument at the moment, per se, to print. Now, it is still a little weird. It's as though I've deployed some addition here arithmetically, but that's not the case. Some of you have programmed before, and plus, some of you might know, means what in this context? So to combine, or more technically, anyone know the buzzword? Yeah. To concatenate. So to concatenate is like the fancy way of what Scratch calls joining, which is to take one string on the left, one string on the right, and to join them together, to glue them together, if you will. So this is not addition. It would be if it were numbers involved instead. But because we've got a string, hello, comma, and another string implicitly in this variable based on what the human typed in response to this getString function, that's going to concatenate hello, comma, space, and then David or Carter or whatever the human has typed in. But it turns out there's going to be different ways to do this in Python. And we'll show you a few different ones. And here, too, try not to get too hung up on or frustrated by all of the different ways you can solve problems. Odds are you're going to be picking up tips and techniques for years to come if you continue programming. So let's just give you a few of the possible ways. So here's a second way. You could print out hello, comma, David or hello, comma, Carter. But what has changed? In the previous version, I used concatenation explicitly. And the space here is important grammatically, just so we get that in the final phrase. Now I'm proposing to get rid of that space, to add a comma outside of the double quotes as well. But if you think back to C, this probably just means that print, similar in spirit to printf, can take not just one argument, but even two. And in fact, because of this comma in the middle that's outside of the double quotes, it's hello, comma, and then it will be automatically concatenated with, even without using the plus, to whatever the value of answer is. And by default, just for grammatical prettiness, the print function always gives you a space for free in between each of the multiple arguments you pass in. We'll see how you can override that down the line, but for now, that's just another way to do it. Now, perhaps the better, if slightly cryptic way to do this, or just the increasingly common way, is probably this third version, which looks a little weird too. And probably the weirdness jumps out. We've suddenly introduced these like curly braces, which I promised were mostly gone, and they are. But inside of this string here, I've done a curly brace, which might mean what, just intuitively? And here's sort of an example of how you learn a new language. Just kind of infer from context how Python probably works. What might this mean? Yeah? Yeah, so this is an indication, because of the curly braces, because this is the way Python was designed, that we want to plug in the value of answer, not literally ANSWER. And the fancy word here is that the answer variable will be interpolated. That is, substituted with its actual value. But, and this is actually weird looking. This was introduced a few years ago to Python. What else did I have to change to make these curly braces work, apparently? Yeah? Yeah, there's this weird f. And so it's sort of like part of printf, but now it's inside the it's inside the parenthesis there. This is just the way Python designed this. So a few years ago, when they introduced what are called format strings, or f strings, you literally prefix your quoted string with the letter f. And then you can use trickery like this, like putting curly braces so that the value will be substituted automatically. If you forget the f, you're going to literally see hello, comma, curly brace, answer, close curly brace. If you add the f, it's indeed interpolated. The value is plugged in. All right, questions on how we can just say hello to the world via Python in this case? Yeah? If you do this without the f, if you omit the f, you will literally see HELLO, comma, curly brace, ANSWER, close curly brace. So in fact, let's do this. Let me go back to VS Code here quickly. I've still got my file called hello.py open. And let me go ahead and change this ever so slightly. So I'm going to go ahead and let's say from CS50 import getString. And that's just the new syntax I propose using to import a function from someone else's library. I'm going to now go ahead and ask the question, let's go ahead and use getString, storing the resultant answer. So getString, quote unquote, what's your name, question mark. And then on this line, I'm going to deliberately make a mistake here, exactly to your question. Let me just say hello, comma, answer. And just this. Now, even though answer is a variable, Python's not going to be so presumptuous as to just plug in the value of a variable called answer. What it's going to do, of course, is if I type in my name, whoops, I typed too fast. Let me go ahead and rerun that again. If I run python of hello.py, type in my name and hit enter, I get hello, comma, answer. Well, let me do one better. Let me apply these curly braces as before. Let me rerun python of hello.py. What's your name? DAVID. And here's again the answer to your question. Now we get literally the curly braces. So the fix here ultimately is just going to be to add the f there, rerun my program again with DAVID, and now hello, comma, David. So this is admittedly a little more cryptic than the ones with the plus or the comma, but this is just increasingly common. Why? Because you can read it left to right. It's nice and convenient. It's less cryptic than the %s. So it's sort of a new and improved version, if you will, of printf in C, based on decades of experience of programmers doing things like this. Questions on printing in this way? We're now on our way to programming in Python. Anything? All right. Well, what more can we do with this language here? Well, let me propose that we consider that we have, for instance, a few other features that we can add to the mix as well. Namely, let's say some data types as well. So let me flip over here to back to the slides. And there's different data types in Python, as we'll soon see. But they're not as explicit as we already saw by using a string from getString. You don't have to explicitly state what it is, but you saw, recall in C, all of these various data types. And then in Python, kind of nicely enough, this list is about to get shorter. And so here is our list in C. Here is an abbreviated list in Python. So we're still going to have strings, but they're going to be more succinctly called strs now, str. We're still going to have ints for integers. We're still going to have floats for floating point values. We're even going to have bools for true and false. But what's missing now from the list is long and floats. And why is that? Or rather, long and double. Well, recall that in C, those used more bits. Well, in Python, the smaller data types previously, int and float, themselves just use more bits for you. And so you don't need to distinguish between small and large. You just use one data type, and the language gives you a bigger range than before. It turns out, though, there's going to be some other features as well of Python, these data types, one of which will be called range, another of which will be list. So gone will be arrays. We'll actually use something literally called a list. Tuples, sort of like XY pairs for coordinates and things like that. Dict for dictionaries. So we'll have built-in capabilities for storing keys and values, we'll see. And even a set. Sort of mathematically, a set is like a collection of values, but it automatically gets rid of duplicates for you. So all of these things we could absolutely implement in C if we wanted. And indeed, in problem set 5,